All right, welcome to day 22 of Advent of Code 2024. Today I took about 22 minutes to solve the puzzle, so you're going to see live footage, uncut, of me doing that, and then I'll have an explanation at the end for both parts of the puzzle. So let's get started with me solving the puzzles live. All right, welcome to day 22. Let's get started with the puzzle. Okay, seems like what we got to do is define mix and prune functions. So mixing is just a bitwise XOR. Prune, we gotta take something, mod this. And we need to find a pseudo-random number generator. Okay, I'm going to override the default next function. Seems like we're going to multiply by 64 and then mix it into the secret number. So we got to mix x with x times 64. Oh, so this is just left shifting by 6 bits and then pruning that. I wonder if this is power of 2. Is math.log2 a function? Okay. Yeah, so it's 2 to the 24. Okay, interesting. Don't know why my mouse is disappearing. Okay, next we got to divide by 32, rounding down, and then mix it, and then prune it. So we're right shifting by 5 bits. And then we gotta do the same thing, but with 2048. Okay, so we're doing some bitwise operations here. Okay, interesting. Okay. Okay, something's wrong with VS Code. Let's see if this is correct. None type and int. Okay. Oh, okay, we forgot to return here. Okay, that worked somehow. All right, part 2. Four consecutive changes. This is tough. So we need to look at all possible sequences of 4 changes, and then we sell immediately after. -1, -1, 0, 2. So the 2 is associated with the 6. And then we sell when it hits 6. How many possible sequences of 4 numbers are there? Well, there's 2,000 numbers in each sequence. And there's 1,500 buyers. So that's about 6 million. Each one will take a long time, because for each we need to iterate through each. This is going to be 6 million squared, which is quite a lot. Okay, that is tough. Well, actually, I think we can do this if we use sets. We're going to straight bash it. So we're going to find this function here which generates the entire sequence of 2,000 numbers. We also want to yield the price change. Okay, what if we just create a dictionary for the sequence of changes and their associated prices? And then we store all of these, and then we just run through all of them. I think that's feasible. So we're going to do so profit is going to be how much we earn for a given key of 4 changes. We're going to have a sequence start here. We really only need to keep track of the last 4 changes, but it's okay. Sequence out of range. Okay. Oh, then we need to append the sequence. Okay. Oh, it's only the last digit. Okay, so it really only cares mod 10. So -1, -3, 6, -1. Okay, so really we only want to start looking when I is at least 5. 6, okay. Oh, mod 10. Okay, this should be legit, I think. Okay. Okay, we're going to use TQDM for progress bar and just see how long this takes. Okay, that was very fast. So generating the maps is quite good. Okay, so this is going to take in a sequence of 4 price changes and then look up the total profit. Okay. So we're going to create a set of all the unique ones. How are we going to do this? Well, we're going to... it's iterables.chain. You could just use a for loop. Okay, union with an iterable, which is profit.keys. So now sequence is going to have everything. Okay, so that was not what we expected. Okay, we have a list of all sequences. Get total profit then is probably wrong. Okay. 9. Maybe, quite possibly. Okay, let's test it on this input. And we're not going to print this out because it's too big of an input. 27. $27 is higher than I expected. Oh, first occur. Okay. So really we want to be doing this in reverse order. So it could occur twice. 25 is still too high. Okay, something's wrong with my VS Code, so I'm just going to reload the window. Okay, sorry about that. Is this better? Cursor is still not appearing, which, okay, here it is. Oh no, it's gone. Let's look at the first one. So for the first one, the change we want to look at, sequence changes, is this. So we're gonna do that. 8. That's not right. Let's just generate the first 20. Key error, okay. That's correct. And we want to look at, say, let's say the initial price is 1, 2, 3. And then -1, -1, 0, 2. Should return 6. So it's 4. That's not good. I think it's associating it with the wrong one. So I think it's associating it with the next one, which is not what we want. So maybe this. That's also not what we want. Oh, we're running part 1. Okay. Okay, it's still returning 4, which is not good. X want 10. Even if we do this, well, what if we append it to the sequence earlier? Still 4. That's weird. Okay, this should help clean it up. So when it is -1, 0, 2, it's to 6. But X is 1, 2, 2, 4, 9. Okay, that's a bit too early. One, 2, 2, 4, 9, 4, 8, 4. Yeah, that's slightly too early. That's like one step too early. So what if we did this? 2. Okay, that's not what we want. What if we did this? Still 4. It's not what we want. 1, 1, 1, 0, 5, 4, 4. Also a little bit closer. So what if we really just need I minus 2, I plus 1? Index out of range. Okay. Something is definitely wrong here. Okay, now we're getting the right answer. I don't know why, but it's working, so I'm not going to complain. Nine is not correct. Oh, because I'm only doing 20. 23. Okay, that's the right answer. Something tells me it's going to be a little bit off, but it was not too bad. Put TQDMs here. Oh, okay. Let's finish running. 1555. Okay, great. That's it for day 22. Okay, today was quite interesting. Basically, we're doing a pseudo-random number generator. The idea is that we start with a seed, and then we generate a sequence of numbers, and we have to find the 2000th number in the sequence. So for part 1, this is quite easy. All we need to do is just implement the process. To get the next number in the sequence, we multiply the previous number by 64, and then mix it, which is just taking the bitwise XOR of that result with the original number, and then we take it mod 2 to the 24, which is what pruning is. And then, after we have that number, we divide it by 32, rounding down, so basically right-shifting 5 bits. Mix it, so take the exclusive OR, and then prune it. And then finally, we multiply the secret number by 2048, mix it back into the number, and then prune that. So essentially, we're doing a bunch of bit shifts and XORs, and pruning it by taking it mod 2 to the 24. We do this a total of 2,000 times and find what the final number is, and that's going to be for every single line. We add up those numbers. In Python, pretty simple to implement. We have a mix function, which is the XOR, and then the prune function, which is modding 2 to the 24, which is a literal that they give you in the problem. And then we have this function, which generates the next number in the pseudo-random sequence. And then we do this 2,000 times for every single number in the lines, and then add that together to get the answer for part 1. For part 2, things get a little bit more complicated, but essentially for every single sequence, instead of taking the whole number, we just take the units digit. So that's going to be another pseudo-random sequence, which is generated by the original sequence. What we want is for every single buyer, so there's a buyer, which is every line in the input, and every buyer is going to generate a list of 2,000 numbers, which are all single-digit numbers. We want to tell a monkey to sell at a certain point in every single sequence. So it can sell at a distinct index in every sequence, but the restrictions are it can only sell after a sequence of 4 price changes. So for example, if these are the original numbers in the sequence, then these will be the price changes. It goes from 3 to 0 to 6 to 5 to 4, so on and so forth. And the price changes are going to be -3 from 3 to 0, 6 from 0 to 6, -1 from 6 to 5, and so on and so forth. So these are the price changes. We calculate it for every sequence, and we need to tell the monkey a sequence of 4 price changes to look for. And then for every single buyer, it'll look for these price changes and then sell at the end. So, for example, if we tell it to sell after -1, -1, 0, 2, then it'll sell at the 6th point, and we get 6 for that sequence. We're only allowed to choose one sequence of 4 distinct numbers, so that's a pretty big restriction. And we get total number of bananas, or like our payout is the sum of the sell points for every single sequence. If our sequence of 4 changes doesn't appear in any of the buyers, then we don't get any money for that buyer. So the question is, what is the ideal set of 4 changes, and how many bananas do we get? So this is not too bad to bash out for part 2. Essentially, what I did was there's only 1,500 numbers here, and each one, or every seed, generates 2,000 numbers, and that means we have about 3 million total sequences to look through. So that's not too bad. And for every single sequence, we can make it a little bit faster by making a dictionary that maps the sequence of 4 changes to look for to how many bananas we get for that sequence. So that's going to make lookup a lot faster, because we only need to do 6 million lookups, and then one of them per line. Actually, let's take a look at how many distinct sequences there are. So let's print the length of the sequences. I'm assuming there's about 6 million, but we will see. So it's going to take a little while to calculate all of the sequences. And it turns out, oh, it's not going to print out yet. Okay, there's only 40,000, which is a little bit surprising. 40,000 unique sequences. Actually, does that add up? That adds up, because price changes can only be between 0 and 9, and you have 4 of those. So it's 10 to the 4, which is about what we expect. So it's a little bit extra, but 40,000, that's not too bad. Okay, so how exactly we take advantage of this is for every single buyer, we generate all of the 2,000 numbers. That's what this loop is. We're using the same logic as part 1 to generate the sequences, take it mod 10, and then if we're far enough down the sequence, then we can look at the previous 4 numbers and then calculate the price changes, which is what this is. And then we put it into the dictionary saying these 4 sequences, these 4 changes correspond to getting this many bananas. And that's going to be stored in the profit dictionary. And then we return the profit dictionary at the end so that we can amalgamate our list of 1,500 price change to banana mappings. And then we get all distinct 4 change sequences and figure out how many bananas each of those gets using this function. And this function just runs through all of the different buyers, checks the sequence, and then adds that to total. And then we find the most profitable one using a simple for loop over here. To optimize things a little bit, we have this loop, which determines all the unique sequences that do appear. So that cuts us down from, all possible sequences, which is about 10 to the... Actually, it's going to be 20. 20 to the power of 4. So that's quite a big number. But we can cut it down a little bit by only checking the unique ones in that for loop. And then for every single one, we look at how many bananas it gives us and then take the maximum of all of those for part 2. And that's it for day 22 of Advent of Code 2024. We're getting pretty close to the end here, so I want to say thanks for watching. If you want to check out my code, it'll be linked to in the description. Any questions or comments, feel free to leave those down below as well. So I'll see you tomorrow for day 23. And that's it for day 22. As usual, if you want to check out my code, it'll be linked to in the description. Any comments or questions, feel free to leave those down below. Thanks for watching, and I'll see you tomorrow for day 23.